Okay everyone, let's get into our next tutorial, which is surfaces. Surfaces tutorial can be found on clicking on the question mark in SolidWorks, clicking on tutorials, and clicking on all SolidWorks tutorials, and then clicking surfaces. Now I want to start off by saying this tutorial is one of the most important tutorials you can do as a beginner. Surfaces are fundamental to creating complex geometry for your product designs. And I think in this tutorial in particular, I remember doing this tutorial as a beginner and taking the lessons from this and expanding and growing on those as I continued through my early time in SolidWorks. It's actually a really good tutorial, probably one of the best tutorials that's inbuilt into SolidWorks. So it'd be really interesting to see if anything else comes from it, doing it again 15 years later. So let's get into it. I'll read out to you the overview. So surfaces are a type of geometry with zero thickness. To create surfaces, use many of the same methods used to create solids, such as extrudes, revolves, and sweeps. Surfaces also use other functions or features such as trim, untrim, extend, and knit. Surfaces have advantages over solids. They are more flexible than solids because you don't have to define the boundaries between the surfaces until the final steps of the design. This flexibility helps product designers work with smooth, extended curves, such as those used in automobile fenders or telephone housings. It's a bit of an old reference there. In this lesson, you start with an existing sketch composed of lines, arcs, splines, and sketch points. Then you apply the following surface features to create a nozzle. What is important here that it doesn't necessarily tell you in that overview is that that surfaces and solids are kind of interchangeable in SolidWorks. You can go from a solid to a surface and a surface to a solid in very limited steps. And if you didn't know already, whenever you are exporting geometry for any kind of production, tooling, manufacturing, drawings, almost always it will be a solid body. Okay, so surfacing is part of the method to get to the solid body that you want in your design. All right, so let's go check it out. First up, creating the base. Now we're going to click here to open the file, and we can see in this file here there's a lot of planes set up and a lot of sketches. Now these sketches that you can see along here are many of the types of sketches that you might yourself generate as you are creating surfaces. We're going to save as so that we're not overriding the existing tutorial file, and we'll save that on our desktop with everything else. And we're going to save it as nozzle_01. Okay. So we're going to click to start lofted surface. Now, the main thing you'll notice here is the surfaces, all the surface tools are on their own toolbar. So on the command manager, you can see we've got features, which is everything we've used so far. But when you click surfaces, it's its own toolbar with a lot of the same type of icons: extrude, revolve, sweep, loft. But here they are surfaces and not solid bodies. We're going to click lofted surfaces. We're going to select sketch 2, which is the bottom circle, and then sketch 3, which is the top circle. And we can see very quickly, this is a basic loft between two circles. Now, if I just go to a top view here, you can see that it is only the surface. So the preview that we see is just on the outside area. To get a better picture or better view of that surface, in your feature manager, over on the side here, you click curvature display, and then you can click mesh preview, and it will show you a bit more detail to how that surface looks. Now, in this example, they want us to do some start and end constraints. So start constraint will be your starting sketch. So if you have, well, you'll always have a start and end profile. We only have 2 sketches used here. So our start profile is the first one we selected, sketch 2, and our end profile is the one at the bottom, sketch 3. Sometimes you'll have multiple profiles, 3, 4, 5, 6. Your start will always be the first and end the last. These end constraints, they're going to change how the lofted surface reacts with those start and end profiles. So here they want us to go select normal to profile in start constraint, which is here. So we click where it says none, we click normal to profile and set the start tangent length and end tangent length to 0.5. They want us to do it for both. So normal to profile in both. And we're going to change the length to 0.5. So we're not changing the angle, we're just changing the length. And we can see with our mesh that we've got here, our mesh preview, you can see this line that comes up the side. You can see it's got a little bit of a curve to it now at the top and the bottom. That is what the normal to profile is doing to us, or doing for us. Normal to profile means where the profile is, 90 degrees would be normal to, okay? So at 0 degrees there, it's gonna have a little bit of angle as it comes in, okay, to be at a 90-degree angle to the profile, normal to. Click OK, let's move on. There's gonna be a lot of little tips and tricks in this tutorial. Hope it's very valuable for you. Next, the swept surface. So with swept surface tool, we're gonna create the nozzle grip. To define the finger hold of the grip, include a guide curve in the surface sweep. I'm gonna select swept surface, select sketch 6 for the profile. So sketch 6 will be the shape at the bottom. So we're doing the handle over here. So that is our sketch 6. For the path, we're going to select sketch 4. Now, if I'm not sure which one is which, I can see they've got the arrow here on the tutorial, but I can always open up my little feature tree here by hitting the C key, and I can just find sketch 4 and I can click it. There you go, and you can see the first preview. Now, in this sweep curvature display, mesh preview is already selected. If we uncheck, you don't see the mesh. Now, under guide curves, which is a little drop down, we're going to click in that box and we're going to select sketch 5 for guide curves, which is this one. And then select merge smooth faces. Okay, that is on by default. So we'll leave that on. And you can see what's happening with the sweep. If I explain what's happening here, sketch 6 is our profile. Sketch 4 is our path. So that profile is going straight up along that path. But then a guide curve is going to modify your shape and guide one of the edges or one of those surfaces along that section. So where we have a guide curve here, which is this purple line going up across the front edge, when this lofted profile gets around there, it's actually going to come in and out like that sketch you see. Under options, clear merge tangent faces. So I'm going to go to options and leave that unchecked. And then click OK. All right, fantastic. Next step, the swept surface. Create the exit nozzle. Create another swept surface for the exit nozzle. So we do the same thing. Swept surface, sketch 9 for the profile, sketch 7 for the path. That's the bottom one. We can see it just kind of curls straight down. Under guide curves, we're going to select sketch 8 for the guide curve. And that is really going to stretch out that profile. Select merge smooth faces, that is already selected, and then click OK. It's a very straightforward one. Next. Now split lines. Split lines are a really powerful tool for changing or splitting existing faces. Now faces can be on surfaces or on solids within SolidWorks. I use split line quite a bit to separate sections of a solid body when I'm doing design for manufacture. For instance, you might have a part which is in a mold, injection tooling mold, with a core and a cavity. Okay, now those core and cavities might need draft at different directions, and so your split line might not be at a top edge or where an existing line is. You might have to drop it down a side face. So I'll draw a split line across that area, split it, the top half will get drafted up, the bottom half down. It's one example where a split line might be used with a solid. In this case, what they're going to do is use a split line to split this top surface into a section that's going to better match this one at the bottom. So a split line tool divides a face into multiple faces. This allows you to connect the base, the grip, and the exit nozzle with surface loft. First, split the exit nozzle. So we're going to use split line, which can be found under the sketch toolbar. I've moved it. If you don't already have it here, well, that's where I've put it. You can go and customize your toolbars. All right. So the split line tool comes under mold tools or curves. So if you turn on toolbars and you turn on curves, or you turn on mold tools down here, split line can be found there. Because I use it so often, I've put it on my sketch toolbar, and my curves toolbar can be seen here. So features, curves, split line. That's where you can find the split line tool. So we're going to click split line. Under type of split, select projection, which it is. Under selections, select sketch 10 for sketch to project. So that is the sketch that we're going to project onto the surface to create the split lines. And then select the face of the exit nozzle for face to split. If necessary, rotate the exit nozzle to select the face. That's not necessary. All right, now, at the moment we can't see any preview, and we still can't here, but I expect that this is going to work. So this sketch is done on this plane, all right? It's going to basically extend those lines over the top of this surface and split the face. It's also doing it on the bottom face. That's okay. All right, we're done. Click OK, next tool. And now we're going to do the same thing on the base. Now, I believe this is because, no, absolutely no need for it to be two separate split lines. In the split line tool, you can split multiple bodies at the same time. So one sketch is splitting two different faces. Those faces being from two different surface bodies. And now we're going to create a lofted surface between those new sections. So what you can see with this top one, originally one surface, now we select that, it's actually split up into still one surface, but four different faces. So we're going to connect the three surface bodies using surface lofts. First, connect the exit nozzle to the grip. Click lofted surface, and in the toolbar, select the top segment edge of the exit nozzle, and then the center segment edge of the profile. Okay, that is a loft. Now, when you're creating a loft between two surfaces, when you're creating a loft between two edges, two faces, two sketches, the loft is always going to take the shortest route home, which means it's going to go straight. Now, the shape is not straight because the two profiles are different shapes, but you can see the mesh preview, all these lines are straight, just going from one to the other. We're going to change that. So now if in the loft profile, if the profile for the loft is twisted, you can adjust the connector. The connectors are these green points. So if yours was backwards or twisted in any way, you can move those around from side to side. Under start and end constraints, select tangency to face for both. So start constraint, tangency to face. Now, this option wasn't available before because there was no face to go tangent to. It's obvious. This time, because we're lofting from an edge that's connected to a face and another surface, we can use tangency to face. Tangency to face means that the new lofted surface that comes off that existing face, so let's say from the top here, it's going to have a curve that matches that existing face as it starts. You can see the change there. And you can see as well how SolidWorks highlights the face that it's coming tangent to. Now you can change those settings to increase or decrease that tangency. And in some cases later, when using this tool, you may find that there are multiple faces that it could be tangent to. All right, maybe this is a solid object and there's another face underneath that it's connecting to. You can change the face that's selected, or you can flip the direction. All right. Now we're going to do the same thing at the bottom. Tangency to face, 1, and OK. And that has created a new lofted surface between them. Looking great. Next step. We're going to do another lofted surface between these two sections here. So I'm going to go to loft. I'm going to select this edge and this edge. The green connectors are on the same side. That's good. Under start and end constraints, we're going to select tangency. Select the edges on the base. It says set start to 3 and end tangent length to 7. So let's just make sure that we've got the right one selected. So my start one is here on the bottom area. Switch the start and end lengths as required to apply the value of 7 to the side near the grip. So the side near the grip is the second edge, that is the end constraint. So it should be 7 and 3. It looks like the picture. Press OK. Next step, connecting the base to the nozzle. Finally connect the base to the exit nozzle. Click again, lofted surface. We'll go from this edge to this edge. And again, we will do tangency to face and we leave them set to 1. Click OK. Now, you might see that these surfaces have connected. The new lofted surfaces have connected the existing surfaces. I'm just going to click hide to hide the sketches. But what you'll notice is when you look at this surface here, it's got blue lines on these edges. Whereas this bottom loft that we created, all sweep, it has black edges around the middle. What does that mean? Well, the black edge means that both of these faces are connected to the one surface body. Blue edges mean even though these are tangent and they're touching, this is a separate surface body. And I can find that by going to my feature tree, opening the surface bodies folder, and then you can see all the individual surface bodies that you've created, and you can see again that they are independent. They're currently not knitted together, they are separate. All right, next step. So here we come now to knit surface. So join the surfaces you created with lofts and sweeps using the knit command. Knitting surfaces combines two or more adjacent surface bodies into one. Click knit surface on the surfaces toolbar. Under selections, we're going to select everything. Now, you can click them all individually, or you can click and drag a box from the top left over them and they'll select them all. We're going to click OK. We're not worrying about anything else here. And now, if you notice, the line between these two has gone from blue to black. And if I look in the surface bodies folder, I see one surface only. Let's continue. So now we're going to move on to filled surfaces. Filled surface here is enclosing an open area. So we're going to fill each side. We're going to fill each side of the area enclosed between the base of the grip and the exit nozzle using the filled surface tool. To manipulate the curvature of the surface, use the sketch point to constrain the curve. Constraint curves allow you to add slope control to the patch. Click back to display the model in profile. Back, that's this shape here. We're going to click on the filled surface tool and the surfacing toolbar. Select an edge, right click, and select open loop. Now what open loop will do is select everything connected to that edge, which is open. Open means it's not connected to another surface. Open means it is part of that surface, but is open as in it's not connected to another face. Right click, select open loop, and there, that's a pretty quick preview and pretty quick surface fill that's going to save you a lot of time. This tool can be really powerful. Now select all. Open loop finds all edges in a closed loop, creating the surface fill. Under edge settings, select tangent in curvature control. Select tangent and select apply to all edges. Apply to all. So that means that all of these edges are going to be tangent to the faces that are next to them. Sometimes you will want to use a fill surface tool, but you will want the edges to be contact. And the simplest example of this is a chamfer versus a fillet. A chamfer is a typically a 45-degree angle cut, okay, from a horizontal vertical face with cutting material, but it's not tangent. A fillet, the rounded edge, is usually tangent to the top and bottom. So if you are doing a fill tool on a chamfered edge, it might just be contact rather than tangent. With that done, let's continue. So under curvature display, clear mesh preview. Okay, so they want to turn that off, don't know why. Click in constraint curves, that is this box here, and select pull point 1 in the flyout feature manager design tree. That is pull point 1, and that is a sketch point. So let's turn on mesh preview again, and let's deselect pull point 1 so we see what the difference is. So you can see that by default, with all these faces tangent, this is what the surface would look like. And we can increase the mesh density to get a better preview and see where all those curves are going. But what we want to do in this model is actually make it a bit tighter, make it pull in a little bit at the side here. That's what this pull point is used for. That pulls everything in, that little dot that's in 3D space. Under options, we're going to select fix up boundary. What that can do is sometimes fix up any little gaps or small errors that you might have in your surfacing. Okay, just to make it a nice and neat finish. And then we press OK, and now that looks really good. Next, click the front to display the model in profile. Click filled surface on the surfaces toolbar and repeat the process. Now, if our whole model is symmetrical, then you can just use from the front plane, we can do a mirror and mirror this filled surface body to the other side. Now this can be risky with surfaces if your surfaces are not perfectly symmetrical. In saying that, if I was creating this type of object, I might very well have just done it in half to begin with, and then you mirror one half to the other side later. It looks like mirroring that surface fill works well. So I'm quite comfortable with that, and I'm not going to make any changes. The one thing that comes from this though, in that second fill, is under options selecting merge result. So that is here. Now, if you merge result, it's going to merge that surface to the existing surface. If I click that, what we'll find is the mirror doesn't work because we're mirroring the whole body. Instead, what I would want to do is mirror, but I'm mirroring a feature, surface fill. And when I do it this way, it doesn't want to work. So what we can do instead, we have this surface fill here, is uncheck merge result, go back to using the mirror tool. We're going to mirror it as a body, a surface body, and then we can do a knit surface on the after that feature, and we're going to knit all three surfaces together, press OK, and there you have it as basically a similar result. We have an extra step, but I think it's a bit cleaner to only do one surface fill at a time. All right, next, planar surface. Apply a planar surface to close the openings on the grip and the exit nozzle. Click planar surface on the surfaces toolbar, select the edge. In this case, we've got multiple edges because we split that loft earlier, and then press OK. That creates a planar surface there. A planar surface is a flat surface. That is a surface that I could do a sketch on if I wanted to for any reason later on. Okay. We're going to do the same tool, use the same tool, planar surface on the bottom. Select all those edges, press OK. In the graphics area, right click on the edge and select open loop. We've done that before. The 4 sketch entities on the grip are selected for bounding entities in the property manager. Click OK. Okay, we've done that. And then we're going to knit all together once again. Now, this is an example where we've done a knit in our feature tree already. See just down here, surface knit 2. I still have another hole just back here. Did it tell us to do? I did this one in the wrong place. Surface plane 2. So I'm just going to edit that one and delete and redo. Okay. So I can grab, if you haven't seen it before, your feature tree can be reordered depending on the way that you've built things. This surface net cannot be moved above mirror 2 and surface fill because it is using mirror 2 and surface fill to create as surfaces to knit within that tool. However, I can move it down underneath surface plane 1 and 2 because those are independent. And then I can edit surface knit 2, click on the new surfaces and have them included in that knit. It saves me from doing another knit surface feature, keeps my feature tree a bit cleaner, a bit more organized. Let's continue. Knit all surfaces. Okay, we've done this. Save the model. Now we're going to do a revolved surface. Use the revolve surface tool to create a surface that extends the nozzle base. Select sketch 13 in the feature manager tree, who's here, and click revolved surface here. Property manager under direction 1, select blind and select angle to 360. Both of those are done. Click OK. Now you can see it. I'm just going to hide this sketch that we won't use anymore. Next step, move copy bodies. All right. This is a very cool tool as well. Move the revolved surface and position it below the existing nozzle base with the Move Copy Bodies tool. This tool moves, rotates, or copies bodies and surfaces and places the bodies in any position using coordinates. Click Move Copy Bodies on the Features toolbar. It is here under Mesh Modeling. Again, I use this tool so much that I have moved it to a hotkey. I'd use Alt-M for Move Copy Bodies. To create a hotkey, you right-click on your command manager, you go Customize, click on Keyboard. Search for your command, Move Copy Body, and you can see here for Insert, Move Copy Body Feature or Surface, I have the shortcut Alt and M. To do that, press the keyboard shortcut that you want to put in and press OK, and it's done. So what SolidWorks is asking us to do, the tutorial is asking us to do here, is use Move Copy Body, uncheck Copy, select the Revolve, clear Copy, which we just did. Under Translate, set the Y distance to negative 6.35. And we're going to move it down and click OK. Now, why I know it's the Y axis that I want to move it along? Well, in the bottom left-hand side of your screen here, just to the left of my face, you can see a Y, X, and Z axes. Now, we've been told to move this body down. If I look at which direction is down or up in that axis little icon there, I can see the Y direction is up, which means negative Y will go down. There you go. Okay. And next, now we're going to trim surface. Using the mutual option of the trim surface tool to remove extraneous faces. The mutual option uses multiple surfaces as multiple trim tools. Trim surface, again, super powerful tool. Trim, I'm going to select mutual for the trim type. Under surfaces, I'm going to click both surfaces, so top and bottom. I'm going to select remove selections and I'm going to click in that little box there. And now I can see a yellow preview. And now I can see a yellow preview on the screen. And it's asking me to click pieces to remove selections. So click pieces to remove and select the faces shown. I'm going to select that top outside face, that bottom outside face, and then the end result, you can see that it's kind of got a nice join just up there. You can select the faces for pieces to remove in any order. The list that appears in pieces to remove is based on your selection order, not on the entity you select. When done, press OK. And what that surface trim tool has done is removed those extraneous faces and then knitted together what is left. Awesome. Now, next step, extruded surface, creating a trim tool. With the extruded surface tool, create a trim tool at the base of the nozzle. Trimming the surface creates the first notch on the nozzle base. For clarity, switch to display to hidden lines visible. I don't think we need to. We'll skip that. Click extruded surface on the toolbar under direction 1. We're misselecting the sketch. Select sketch 14, which is this bottom one. Select extrude, select mid-plane and change the depth to 140. And what we're doing is creating an extruded surface, which is going mid-plane here, 140 millimeters. Click OK. Next step, we're going to move copy bodies. To create a second intersecting trim tool, move and copy the surface extrude you created in the previous step. So I'm going to use my keyboard shortcut, Alt-10. Doesn't want to work. Hold on. Alt-10. There we go. I'm going to select that body. I'm going to select this time copy. Number of copies is 1. Expand surface revolve in the feature manager design tree. Okay. And right click sketch 13 and show. Let's find sketch 13. Oh, this is tricky. Now, if I can't see sketch 13 there, it must be because it has been consumed by an existing or another feature. So I'm just going to press the little drop down arrow next to these features until I can see 13, and there it is there. So I'm going to right click on that one and go show, and then I can see that construction line that was gone right up the middle. So I'm going to under rotate, I'm going to select in the rotate position here, that line, change my angle to 90, and you can see the preview, press OK, and now we have 2 extrudes running either way through the bottom of that surface. Now we're going to trim surface. Create this first of the 2 cuts at the base of the nozzle with the trim surface tool. Select trim surface. Now we're going to go back to a standard trim type. I think you could do this in mutual and do it in less steps, but for the sake of the tutorial, we're just going to follow the standard tool one. We're going to select this surface body move copy 2 as the trim tool, and then we're going to select keep selections. So we change that option, and then we're going to select the main section above, and then press OK. And then we're going to hide that body. Now you can see we've trimmed out that section of the surface all the way through. Now it's going to ask us to do the same thing with the other one. So select trim surface, trim tool is this, keep selections is this, and then hide this body. And then we have that 4-way cut. Awesome. Looking really good. Delete keep body, deleting trim tools. Delete the surface extrude and the surface body created with the move copy tool. These entities were used to trim the model and need to be removed for the final thicken surface operation. That's not 100% true. You can just thicken by selecting a body and then it will thicken it. We don't have to delete other surface bodies first. They can remain. But if you want to keep your bodies in your file clean, then you would delete them. So delete keep body is here on my feature toolbar. I've customized my toolbar to put it there. It can also be found under features, insert feature, delete keep. Now we're going to press keep and I'm just going to select the surface. And that's it. It's deleted everything else, any other surface or solid bodies. Now, next, untrim surface, so patching a surface. To strengthen the base of the model, use the untrim surface tool to patch one of the surface cuts. Click untrim surface on the surfaces toolbar, select edge 1 in the graphics area. So we're going to select untrim, select edge 1. The untrim surface tool extends an existing surface along its natural boundaries, so you can select any edge from surface trim 3. Under options, select extend edges, yep, and merge, yes. Click OK. Now, untrim is basically like a fill tool, all right? It doesn't have the same or require the same inputs. I didn't have to select all the faces, but it filled in that gap. Again, very powerful, neat little tool. Now, the last step, as I mentioned at the start of this tutorial, with any surfaces in SolidWorks, typically you will want to turn them into a solid body before you're exporting or creating drawings, etc. This is how you do that. We use Thicken surface, creating a solid. Thicken the surface model to create a solid model. We press the Thicken tool. In the property manager, under Thicken parameters, select surface untrim. So we're going to select this body. Click Thicken side to number 1. So that will be on the outside, and set the thickness to 0.5. So you can see the thickness setting here. If I change it, it's going to change the preview to both sides or the inside. We want to go on the outside and click OK. And now this is a solid body. You can see the folder has changed from solid bodies to surface to solid bodies. If I do a section view, you can also see there's a wall thickness here. All right. Whereas previously a surface, if I just roll back, a surface has no thickness. So if you do a section, you will see a blue edge. There you go. And save the model, and congratulations, you've completed this tutorial. Nice one. Thanks for watching this video. I hope you found it helpful and found something new to enhance your SolidWorks skills. Don't forget to subscribe to Fully Defined for more tutorials, tips and insights from a certified SolidWorks expert. Hit the bell icon so you never miss an update. If you have any questions or topics you'd like me to cover, leave a comment below. I read all comments and love hearing your feedback. Remember, with the right skills and tools, you can turn your design dreams into reality. Keep modeling, keep learning, and always fully defined.